So now I want you to drive you through the fact that the condition 2 is purification 1 with spy error that we introduced implies the condition 1 without it, let's imply that we have first we can write like a pure state as the formalism of a mixed state, I think. So basically, if we take the density matrix of rho AR, it will be like equal to CRR CRR with CRR being, sum of x or square root of p of x, as we saw, because for like cx or xr. And so if we apply now um, our compression uniquely on the system A, because the spy R is being untouched, let's call it like compression. Like it's decoding encoding stuff maybe. So yeah, we have basically, because right here does this with a brown cat, we just write it 2 times sum of x y of the square root of px py, respectively for a and r of cx cy of a xor x y of r. By the way, if you want to know why we used we want to take density matrices, it's just because channels are a completely positive thread preserving map, and so the trace, like both of them, need like density matrix to work about like the trace term, like you need density matrix, and also the channel needs it too, because quantum channels cannot be applied on isolated ket within density matrix. So we are like in a way less or more it's mandatory like to go to the global matrix. So yeah, for the two reasons of the channels and the norm. And so yeah, so basically we have this. Uh, and because the channel, just applies on on A and not on R, we can like just write this is equal to sum of x, y, square of px, py, of px, py of a, excuse me, because it's apply on a, which just need to put decoding and coding on it, coding and coding of px, py of a, xor xy of r. So that's the first step. The idea after is just to take, I would say, okay, R is like orthonormal, with where we said like we had X in our stuff, like here it should be orthonormal, and so because of it, we can like just take a projector that project about it, and that let A intact, but that will check about R. So if there is no uh, it will just take us all stuff correctly and eliminate all the ones that are not really here. If you want to be like more accurate, and it's to be more pedagogical, um, I can say we have more like the sum of x of like literally what we have before. Trace this, we already take this, just the sum of x of the square root of px py um, of ai px py a ai xor kk r xy r kk of r. And so you see we have here the two delta kx and delta k um delta kx and delta yk, and so we need k to be equal to x, and so we just need to have at the end um, pk, because we have like p squared, so um, pk of like pk of pka 0 k k of r, and there is no sum anymore because like we just have like k as index. We need x equal to y, so there's now only one step. So it's just like predictor that we apply to never aware, and so for this one you can do the same. You just have the sum of x of y of square root of px py of ai of decoding encoding px decoding encoding and px py of a xor x xor kk um, of xy kk, so it will be the same, annihilation of them of delta kx delta yk, and so you just retrieve the same. You just have like pk of decoding encoding of px py of a 0 kk, not 0, yeah, um, yeah, 0 kk, and that's it. And so you have this, and so at the beginning it was just a minus here, so if you take the form about it, um, it just at the end, if you factorize by those, you just have like pk of ck c, like maybe it's better to write it directly here so you got the idea. So So you have like pk of ck as a pretty of k multiplied by, sorry, pretty of k multiplied by ck a minus the coding and coding of ck of a xor kk of r. Yeah, it's just a simple algebraic elimination where the spy R just have perfect memory and orthogonal to each message. So by bursting on K, we just force the system to forget all messages. So just X is different of K and Y different of K to just keep only the pure form of K that will be isolated at the external of the big sum. So that's why we did not choose a trace, because we were not able to isolate. And so at the end you just want to isolate the sum of x by x, because you want to go from here to here, and so you just need to isolate the sum about it. And so basically when you have that, like, what you need to remember is, like, when you apply some kernel, like those projector that are defacing kernel, those projectors, then by a fundamental property of the norm, the trace norm, like quantum operation can never increase the distance um, between two states. So when you have applied this predictor Q, K, K, and R, then you just have like this being like inferior to our initial stuff without this application of K, K of on R, you know? So that's just inferior to our stuff before the application of the kernel. And by injecting like the result we just have here, you know, because it's literally equal to this, it's what we calculated before. We just have like, because we saw like with the stuff it will annihilate the stuff itself. It will just be the sum of k of pk of and indeed we have like sum of k of pk, because we know before we had pk, but it was just only about one of them, but now we about all of it. So yeah, by injecting the result we had before, we just have like c k pck of a minus the um, epsilon rho a r xor k k sorry, minus the epsilon of ck a xor k k r is inferior to rho r minus the epsilon rho r a r. Because the projectors kk go into directions that are strictly orthogonal, the norm of the trace of a sum of orthogonal blocks is just equal to the norm of the sum of the norm of the trace. And the norm of the spy part kkr just is equal to 1, so you can just extract uh, what does not depend of kk, because it's equal to 1 and equal to sum of k of pk, oh sorry, pka minus the sum of decoding and encoding of pk ck of a1 is inferior to rho ar minus d coding and coding of rho r. And so yeah, with this being like, so you just can do 1 over 2, 1 over 2. And of course, like, because we wanted the power of n, like, these are more forgetted about it, but like here, you take 0 of n, here 2, like, it's 0 of n, like here, power of n, okay, n, well, everywhere, we can put some n. Um, but yeah, we can say in a way it was like we write it directly like this to not lose really time about it, but yeah. Mm, everywhere. And. So yeah, and yeah, so we have as from level once it ends. Let's put n everywhere. But yeah, basically that's the idea about it.